Well, hello. Good morning from Vienna, but wherever you're connecting from, hope you're having the best day, morning, evening. Hope it's not too late there. Oh, okay. Yeah, let's see where people are connecting from. From Borneo, Malaysia. Wow. Hello. Good to see you. Let's see where else from. From Burkina Faso. Hello. From Zambia. Hello there. Good morning from Hungary. Love it, love it. We're desde España from Spain. Hi. Good evening from New Zealand. My goodness. Hi, Alan. Good to see you. From Sydney, Australia. Hello. From the US. From Pakistan. Oh my goodness. From Germany. I love seeing folks connect. From Argentina. From all over the world. Liberia. Wow. This is absolutely stunning. From India, hello. From Jamaica. This is wonderful to see. And thank you all so much for connecting today. And well, if you're wondering what you're doing, if you've connected and you're like, what's going on? We're doing a little bit of JavaScript. We're doing a free boot camp in collaboration with Class Central and using the materials from FreeCodeCamp. This is the second last lesson day. My goodness, how time flies. Couple links before we get started. First off, if you need to find the materials, please go to classcentral. Let me try this again. There we go. classcentral.com. There you'll find all of the materials as well as being able to track your progress. Here you've got freecodecamp.org for the materials themselves, as well as that's where you'll get your free certification once you're done. If you need to ask questions, as always, go to group.classcentral.com. There's also a Discord link if you want to, join that and, talk more synchronously. We've got a code of conduct that we expect learners to abide by. If you need to report something or if you've got any feedback for us, please send us an email at bootcamp@class-central.com. Oh, we got a couple more folks connecting from Indonesia, from España, from Spain, from Italy, from Nigeria. It's just wonderful. And yes, thank you very much, Kiki. Here is the link to the Discord community if you ever want to join that. Yeah. So what are we doing today? Let me bring up my screen real quick and hop right in. So let's catch up on what we were doing yesterday. Yesterday, we did functional programming. We went a little bit overtime. Sorry about that. I just really like functional programming, and it's a lot to take at once. So homework was to do the rest of the lessons. We did 15 out of the 24 lessons. And so, yeah, the homework was to do the rest of them. If you have any questions about these, by the way, we can always, please, say in the chat, like, hey, can we go through this one? And we can do that during the Q&A at the end. However, today we're going to be doing intermediate algorithm scripting. Now, you remember, I think it was last week, yes, that we did basic algorithm scripting, to sort of start training ourselves on how to solve complex problems in JavaScript. Today is kind of like the big day of like, all right, we're going to do the intermediate scripting now. So now that we know the basics of algorithmic thinking, and now that we've learned functional and object-oriented programming, we're going to be testing our skills. Now, none of the concepts introduced here will be new per se. We'll be able to solve all of these problems using the skills that we've picked up along the last 5.5 weeks. Now, what this means is that I will be showing you how I derive the solutions, how I come up with the solutions. I encourage you to propose your solutions in the chat. I encourage you to go and try them out as well. We're not going to go through all of them today because there's a lot of them, and I want to take my time and really think about how I'm solving these problems. And I want to be very clear. You've probably seen this as we've done the projects. I'm not going to have the most efficient or the best looking solution, and that's okay, because as long as it works, we're good. And we can talk about how to make them more efficient or easier to read. I'm a big fan of making code easy to read, especially when I'm collaborating in a project with lots of folks and, my code needs to be understandable. With all that said, yeah, let's hop right in. We're going to sum all of the numbers in a range. So that's our first exercise. I'm going to click right here. On the left, you'll see the instructions. On the right, you'll see the code, as well as below that, you'll see the console output. So I'm going to go ahead and read each of them, and then we'll think about how to solve them. We'll pass you an array of 2 numbers. Return the sum of those 2 numbers plus the sum of all the numbers between them. The lowest number will not always come first. For example, sum all 4 and 1 should return 10 because sum of all the numbers between 1 and 4, both inclusive, is 10. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. So that's how we're going to be doing that. Let's see what we got on the right here. We've got a function sum all, which takes an array as an argument, and it returns 1 at the moment. And we are calling sum all with an array of 1 and 4. Now, you'll notice the first thing is that instead of passing in 2 separate arguments, we're passing in an array. So let me just console log this to see, just to keep track of how this is doing. And now that we know from this, 1 plus 2 plus 3 plus 4 should print out 10. But at the moment, it does not. At the moment, it prints out 1 because the function is returning 1. So as always, I'm going to write down some pseudocode. Split up the array into first and second. Now I'm going to expand here a little bit so we have some more space to type. If first is bigger than second, then we'll loop between first and second, adding up. Return sum. Else, and the only other thing that can be the case is that the second is bigger than the first. Loop from second to first, adding up. Return that sum. So let's try it this way. First thing we're going to do is split up the array into first and second, and we're going to be using some ES6 magic. So first, second, R. And I'm going to be console logging that just to make sure. First, second. So yeah, we've got our 2 values now taken out of the array, 1 and 4. Oh, yeah. So if first is bigger than second, if first, I should really say smaller than here. Because that way I go from 1 to 4 as opposed to from 4 to 1. So if first is smaller than second, then we loop between first and second, adding up. Okay, we'll do a for loop. Let I equals first. I must be smaller than or equals to second. And we'll add 1 to I as we go. And we'll be adding up. And in order to add up, I forgot to declare a variable where I need to store my addition. Let's do that. Let's call this let result equals 0. Store sum in a variable. I'll call this sum. I think it's a better name. Cool. For let I equals first, I is smaller than second, I plus plus. So sum plus equals I. And so we go from 1 to 4. First, we add 1 to sum, then 2, then 3, and then 4. Then we return that sum. If you take a look at our, let me remove this console log real quick. If we take a look at our console log, because first is smaller than second, we can already see half of our solution working. We're getting 10. However, if I run the tests, you'll notice that all of the ones where the first member is bigger than the second one, it's not working yet. Let's try this one and put it in our input. Whoops. Let me try that again. There we go. So that's still giving me 1 because this if statement is not passing, so we need to move on to this one here. And we'll do that right away. We'll do an else. What are we doing? Loop from second to first, adding up. And you're going to see this is pretty similar to this previous case. Let I equals second. I must be smaller than or equals to first. And we'll do an I plus plus. Sum plus equals I. And then we return that sum. Nice. That's giving us 10 already. Fantastic. Let's run our test again. And that's passing. We'll pat ourselves on the back. Pat, pat. But I don't know about the rest of y'all, but I think we can already start simplifying a little bit. For example, both if statements are doing a return of sum. So what we can actually do is take that return sum statement and move it out to the bottom. By doing so, we're ensuring that sum is being added up to, but still being returned correctly. We run our tests, and it's still working. But I think there's a little bit more that I can do because, you know me, I don't like to repeat myself. And do you remember, I think it was last week, we talked about the dry principle, don't repeat yourself. We're doing two loops that do very similar things. So what if instead of checking if first is smaller than second, what if we sort those numbers? And you know what I'm going to do? I'm going to, am I going to throw caution to the wind? I'm going to do it. I'm going to take all of my code and delete it. Yeah. Sort. Oh, wait. Split up array. Sort members. Or wait. Oh, I have a better idea. Split up array. Split up sorted array into lower and upper. The lower bound and the upper bound. Loop from lower to upper, summing up. Now, Santa's saying we can use a condition true false. Can you elaborate on that? I'd be super interested to know what where you were thinking this. So, Carlos is suggesting reduce. I'd love to know how to use reduce in this case. Could you elaborate, please? In the meantime, I'm going to try this real quick. Loop from lower to upper, summing up. I need my sum variable. Start sum variable at 0. Loop from lower to upper, summing up. Return sum. So we'll split up the sorted array into lower and upper. So const, we'll do this lower upper again. And we're going to sort that array. r.sort. Remember, to do a sort with numbers, we need to do that subtraction that we did before. So that's num. Oh, wait a minute. It takes two parameters, num1, num2, num1 minus num2. Let's log and see how that looks. Check it out. No matter what order they're in, lower and upper will always be 1 and 4 respectively. Yeah. 1 and 4. Yeah. Cool. Let's start our sum variable. Const sum equals 0. We'll loop from lower to upper, summing up. 4. Let I equals 0. I be smaller than or equals to. That's not 0. It's lower. Upper. I plus plus. Sum plus equals I. And then we return sum. It should not be a const, Ramon. It should be a sum. There we go. A let, sorry. So now we've just got one loop, which is significantly nicer. Run our tests. Still good. Now let's look at what folks are suggesting. Spread it R, reduce sum num, sum plus num. Okay, we'll try that. So the spreaded array is already done. So you're saying, instead of doing this, spreaded R, return spreaded R dot reduce sum num sum plus num. Now this is giving me 5. And you know why, Carlos? It's because we're not actually going through the range between 1 and 4, and instead we're just adding 1 and 4. We actually need to go 1, 2, 3, 4, right? So I'm not sure this solution is going to work. I'll take a moment to talk to answer Sandra's question. Can you explain the function in sort? I did read up on this, but didn't get it why this works with the subtraction. Sure thing. Where is my MDN? I'll just open up a new tab. There's my MDN. Sort. So if we go here and then scroll down to there's a nice table here. Check this out, Sandra. So the return value of this comparison function, that's that function inside sort. If that return value is bigger than 0, then we sort the first value after the second value. If it's less than 0, then we sort A before B. And if they're equals, we keep that original order. So by subtracting num1 or A from num2 or B, we're ensuring that this sort order works. I'm going to post a link here into the chat. Yeah. Aha. So let's see what we're doing here, Carlos. We're looping between 0 and the array max value. Oh, what is this with the question mark? Can somebody please explain to me the as Asante called it, the conditional ternary operator? Because I see it here. So we've got our spreaded array. Okay. For let I equals 0. I is smaller than or equals to our max value, which is spreaded R. Oh, hold on a second. What is the maximum value? Const max equals spreaded R at 1. That's always going to be the bigger one of the two. I plus plus. So we are, let's see, I is smaller than our min value. Oh, we need the min as well. One sec. There we go. So if, oh, sorry, I is smaller than min question mark, R min spreaded R dot push I. Then we do the reduce. Okay. Spreaded. You know what? I want to console log spreaded R real quick. Interesting solution. Let's see. R. So that's giving us 1 and 4, and then 1, 2, 3, 4. Could it be we wanted a new array? Let's call it range. And it's an empty array. So with that range, what we're doing in this loop is building up that range. Cool. And then we can do reduce on the range. Return range.reduce. Sum num. Sum plus num. That gives us 10. I did want to use reduce. Thank you, Carlos. This is pretty nice. Thank you. Well done. Pat to you. Ali, I just want to take a second to help Ali here. I'm having problems submitting my projects on FreeCodeCamp. Is anyone also having problems with that? If you're having problems submitting, first of all, what's the problem? Is it like not working? Is it like not is it ignoring it? Like it would help us if you told us what problem you're having. But that said, hold on a second. Let's go to freecodecamp.org because I think there is a support either in the forum. Unfortunately, I can't help you with the technical side of FreeCodeCamp, but if you go to the forum, or is there a support? I think there's like a support. So if you go to the bottom and look for support, yeah, check it out. Yeah. Here you go. support@freecodecamp.org. Send them an email, and I'm sure they'll be able to help you out. Alistair's saying, I wonder if JavaScript has some kind of spaceship bigger than, equals, or smaller than operator for general comparison. I don't know. Let's save this one for the Q&A. Don't want to spend too much time on not doing problems. So we're done with our first one. That's pretty good. I'm pretty happy with that. Let's submit and go to the next challenge. Okay, this one's called Diff 2 arrays. Quick drink of water and then we continue. Compare two arrays and return a new array with items only found in one of the two given arrays, but not both. In other words, return the symmetric difference of the two arrays. Note, you can only return the array with its elements. You can return the array with its elements in any order. Okay. So what are we saying here? We've got two arrays here, and we want to return a new array. We see here, new array. This function takes the two arrays with all of the elements only found in one of the two arrays. For example, 1 is in both, it will not be returned. 2 is in both, 3 is in both, 5 is in both. Then we'll look at 2. 1 is in both, 2 is in both, 3 is in both, 4 is not. Yeah? Now, how are we going to do this? How are we going to do this? I would say okay, how about this? Hear me out. Concatenate both arrays. Carlos. Oh, index of. Great idea, Sandra. I definitely think we're going to do this. Carlos is telling us about the includes method. Could you elaborate? Maybe send us an MDN link to what includes is? Okay. Concatenate both arrays. Loop through all elements of concatenated array. I will make this bigger. If member is not in array 1 in R1 or not in array R2, push to new R. If it's not in array 1 or not in array 2, then push to new R. Return new R. Let's give this a try. Const. Let's call this one big R. Const big R equals R1.concat R2. Let's console log that. Console log big R. Big R sounds like a big pirate. Big R. So that adds both arrays together. Then we'll loop through all of the elements of the concatenated array for let num of big R. We're looping. Looping is good. So given that we're going to be iterating over the mix of both arrays, we know that those members will be in at least one of those arrays. But what we want to find out if it's not in either of the other two. Yeah. If member, not member, num. Num dot no, sorry, big R. Oh, sorry. Oh my goodness. R1 dot index of num. If it's not in the array, which means not equals -1, or R2 dot index of num is not equals to -1. If it's not in R1 or it's not in R2, then we can new R dot push num. And you know what? I didn't console log. Y'all should tell me to console log. So that doesn't look right. And you know why? Because I make this mistake every time. If it's not in array 1, then we're checking that if it is -1. There we go. Yeah. Yeah. There we go. That gives us 4. Do you know what I'm going to do? I'm going to take this and visualize it. Running. All right. So we start with both of our arrays. Then we concatenate both arrays, make a big array. There's our big R. Sorry. Then we loop through every one of them. So first we're starting with 1. We're starting with 2. 2 is in both arrays. Then we're starting with 3, both arrays. 5, both arrays. 1 again, it's in both arrays. 2 is in both arrays. 3 is in both arrays. But what about 4? 4 is not in R1. So this condition is going to now take place. Yeah, you see the arrows like, all right, let's do some pushing. There we go. Look at 5 again. 5 is in both arrays. So we're good. New R. And our return value is that array. And we're done. Let's see if the tests agree. I forgot to check if the tests agree. I could have been doing this all wrong. Let's see. Yeah, there we go. Pat. I want to try a slightly... Oh. Okay, Carol. How about we just concatenate the two arrays and then change them to set and then back to array? What? What's a set? Let's go to MDN real quick. And let's look up a set. Sets are a collection of values. A value in a set may only occur once. It is unique in the set's collection. You can iterate through the elements of a set. Yeah. That's good. Yeah, somebody's saying, sorry, I'm late for class. Hey, Kuzi, remember, this is all recorded. And if I'm not mistaken, you can even rewind the YouTube as it's going live. So there's no stress. There's no fuss. So let's see. We create a new set with set. And how do we add? Okay, add. Cool. And how do we... returns a new iterator object that contains an array of value in each element set. Here we go. Okay, so we can make a new set. We can add members to a set. Wait. So what happens? What happens if that set already has a member? Let me just try around here. Equals new. Is it new set? I already forgot. New set. Okay. Which, by the way, makes it a constructor or class. So set dot add one console log set. Okay. What if I add one again? Okay, so it only ever adds them once. That's cool. Now the question is, how do we turn an array into a set? This could be really helpful. Wait a minute. I see a problem. Let's go back to this solution. Concatenate the two arrays and then change them to set and then back to array. The problem with that, Carol, is that that's going to tell us, that's just going to give us a set of all unique values. That's not going to give us which values are only in one of them. So Carol says, yeah, we can make it with new set array. That's good, but that's not going to give us which values are. Well, let's try it out. Let's try it out. Let me delete my code. We'll go back to big R. So const set equals new set big R. Console log set. See, that's the problem. The opposite of the union of two sets will give the answer, though. The opposite of the union of two sets. What is the opposite of the union of two sets? You see, that's the problem, isn't it? Huh. Yeah, this is just telling us which unique values are in the array. Which is good. We know that they're 1, 2, 3, 5, and 4. But it's not telling us that 4 is the only one that is in in only one of them. Let's think about this for a minute, and in the meantime, try a different solution, if I may. What if we have two arrays? R1.filter. Let's filter out all of the ones. Let's filter out all of the ones that are not in R2. I want to check out this includes that I've seen Carlos talk about. It says the includes method determines whether an array includes a certain value amongst its entries. Oh, we don't need to do that index of stuff, huh? Array1.includes member. Oh, I like that. Thank you. R2.includes num. Actually, does not include num. Filtered 1. So this is an array of all of the members of 1 that are not in 2, which is not. None of them. 1, 2, 3, and 5 are all in R2. Let's try then const filtered 2 equals R2.filter num R1.includes that's 4. So given we filtered out all of the ones that are in R1 but not R2, and all of the ones that are in R2 but not R1, we can just return filtered 1.concat filtered 2. Let's give that a try. That's a little nicer, I think. Now we're filtering out which ones are in this one and not this one, and which ones are in this one but not the other. And then we just add those two filtered together. Okay, what do we got here? Set one intersection, but set, therefore, the opposite of the union can solve this problem. 1, 2, 3, 2, 3, 5, set intersection, set. This doesn't look like JavaScript. Sorry, I'm a bit confused, Asante. But set 1.union, set 2, 2, 3. Oh. Therefore, the opposite of the union can solve this problem. And how do we do an opposite of a union? I'll tell you what, let's save this. I'm interested. Let's save this for Q&A. Let's move on, do some more algorithmic thinking, because we haven't really done sets much. What do we got next? Seek and destroy. You will be provided with an initial array, the first argument of the destroyer function, yeah, I see it here, followed by one or more arguments. Remove all of the elements in the initial array that are of the same value as these arguments. You have to use the arguments object. I have to what? What is the arguments object? Okay, one thing at a time. What is console log arguments? We got here. In JavaScript, there is an arguments global object that gives us our arguments. Now, given we're outside of a function, it's got a whole bunch of stuff in there that, quite frankly, I don't want to look at. Let's instead look here. Now, this is interesting. Now, inside this function, arguments has 3 entries. 0, which is this array, 1, which is 2, and 2, which is 3. And that corresponds to each argument. Cool. So why can't I just put num1 and num2 here? That would work as well. The problem is, as we'll see here, is that we can have several more arguments. So by using this arguments object, we get access to all of the arguments that was passed in, regardless of whether they were declared here in the function, which is pretty cool because right now R is just that first argument. So here's what we can do. Const. Let's see. Let's do some spreading. So we'll skip the first one and then put all of the ones into destroyers. Now we want to get those values from the arguments object. And you remember to do that, we use object.values arguments. What do we have now? We've got console log R. Yeah. R works. What about destroyers? And there's our destroyers, 2 and 3. What if I put in more? Then I've got access to them now, which is great. So now I've got access to those destroyers. That's job 1 done. Let's see again. Remove all of the elements from the initial array that are of the same value as these arguments. Okay. So we want to return r.filter. We want to, let me just give myself a little instruction here. Filter out all members of R that are in destroyers. Cool. Let's do that. R filter num. And they should be filtered out. So they'll only be included if R does not include, destroyers includes num. Let me console log. So in theory, this should give us, should just return 1. Because 1 is the only one that is not in this group. Let's console log and see how it looks. Okay, right now it's giving me 2s and 3s. That's because I am filtering out all of the ones that are in the destroyers, but I should be filtering out the ones that are not in the destroyers. There we go. So that should, my mistake. It should give us 1, 1, of course, because this one's there. See, I'm still thinking in sets. My bad. Cool, let's try it out with another one. For example, destroyer with this should give us 1, 5, 1. Let's give it a try. Did I do something bad? I did, didn't I? Let's have a look. I deleted a parenthesis. There we go. That gives us 1, 5, 1. Fabulous. So we use some fancy JavaScript spreading to get those destroyers from the arguments. Yep. Let's see. Yeah. Love it. Return our filter element, not values to remove, includes element. Yeah, kind of like I did on line 5. Nice one, Carlos. Cool. Whoa. Oh, look at this. So we're redefining the destroyer to use ... values to remove. Does that work? Let's see. Fancy. But Carlos, we're not following the instructions. It says here we have to use the arguments object. I think this will work. Let's give it a try. So Michael's asking a great question. Why do we need object values arguments? Let's console log object.values arguments. That's because we need this set of arguments here. Now, I think the reason we want this, honestly, is really just to learn that this exists. The arguments object. It's totally doable this way as well. But I think the exercise is trying to tell us like, hey, this exists. You should use it. But I like this better, in all honesty. So I'm going to go with this. Is using the rest operator in the arguments the same as using the arguments object because it also passes the tests? I would say yes. Like what we're doing here is spreading the rest of those arguments. And in fact, the FreeCodeCamp likes it. We'll do a pat and move on to the next one. Yeah. So again, I'm not affiliated with FreeCodeCamp. We're just using their material. They are nonprofit. That depends on, and it's free, super free and open source. So they will ask you for a couple bucks a month, only if you can afford it. Only if you want to, you can give them the money. If not, that's totally fine. You can come back later and get that. I came back much later and gave them some money. I'm doing that on another account though, so that I can have a nice clean account for this bootcamp. So just click on Ask Me Later. Okay. Wherefore art thou? Make a function that looks through an array of objects, the first argument, and returns an array of all objects that have matching name and value pairs, the second argument. Each name and value pair of the source object has to be present in the object from the collection if it is to be included in the returned array. For example, if the first argument is an array of what looks like Shakespeare characters, Romeo, first name Romeo, last name Montague, first name Mercutio. I didn't know Mercutio didn't have a name. A last name. Then first name Tybalt and last name Capulet. And the second argument is last Capulet. Then you must return the third object from the array, the first argument, because it contains the name and its value that was passed on as the second argument. So what this is telling me is we need to filter out all of the objects here that match the values in the second object. So we'll go through here and be like, okay, does this object, for example, we go here first. Does this object have a last name Capulet? Let's see. First name Romeo. Nope. Last name Montague. Nope. Filtered out. Next one. Mercutio. Not a last name. Last name Null. Not Capulet. Out. Next one. First name Tybalt. Last name Capulet. You're a last name Capulet. You're in. So here's what we're going to do. We're going to, let's see what we got here. What's in a name? Collection. That's the collection of characters. And the source is the filtering thing. We've got an array here and we'll return that array. And let's see what's in a name. Okay, we're doing the same thing as the instructions. So there's our Shakespeare characters and there's last name Capulet. So filter function through collection. And inside that filter function, we will return true if all of the keys of the source object are matched in character. All of the keys of the source object, all of the props, I should say, of the source object are matched in character. Let's give that a try. So const filtered equals collection.filter, and we'll do a function with character. Then we'll return true if for all of the keys of the source that matches. Cool. Okay. First, we need those keys. Const keys equals object.keys source. I'll log that. Or log. There we go. Last. Okay. So we'll return true if for keys.every. This was part of the homework. Let's take a moment to look at every. Every method tests whether all elements in an array pass the test implemented by the provided function. It returns a Boolean function. So what does this mean? Let's have a look at an example here. Current value is below 40. We have an array. This will return true if every, and then it calls this function, is below threshold. So if for every member of this array, this function returns true, then array.every returns true. Let's give that a try. So keys.every. Let's go to key. So first thing we want to do is, actually, we just want to say character key is equals to source key. And then we'll return that filtered array. Let's give it a try. I have no idea if this is going to work. Hey, it gave me Tybalt Capulet. I'll tell you what. I'm going to run the tests, and if this is good, I'm going to put this into the visualizer so we can see how it looks. Run the tests. So that's good. We'll do a pat, but I just want to go through and make sure that this looks good. I'm just going to take this code, plug it in here. And big thank you to Sil for showing us this because my goodness, this is great. So we're calling what's in a name. And we'll follow our red arrow. So we've got our R. We get all keys. There's our keys. We can see that they are there. Just the array with last. Then we go through each character. First, we're starting with, and I love this, we start with Romeo Montague. So we go through each key, start with last. Is character key, which is last. Key is last, so the character is this, Romeo Montague. So is character last, which is Montague, equals to source last. And remember, source, we can follow this arrow here, is just last Capulet. So is Montague equals to Capulet? No. So it gets filtered out. Return false. Ah, I love this visualizer so much. Next. Now we're doing Mercutio. Mercutio has last null. So is null equals to Capulet? Return false. Now we're doing Tybalt. Is Capulet equals to Capulet? Return true. So that gets filtered in, and we return that filtered array, which is, hold up, return value. Yeah. Currently empty. And we return that console log. First Tybalt, last Capulet. Fabulous. Let's move on to the next one. Spinal tap case. Convert a string to spinal case. Spinal case is all lowercase words joined by dashes. So we've got this is spinal tap, and it's supposed to turn them into lowercase words joined by dashes. Okay, we can do a little bit of, let's see. Let's first make it lowercase. To lowercase. This is cool, by the way. So I can put the call down here, and JavaScript will understand, you want to do it with string, which is nice. So string.toLowercase gives us this is spinal tap. That's nice. Let's split this string along spaces. Now it's giving us this is spinal tap, and then we'll rejoin them with dashes. This dash is dash spinal dash tap. There we go. That's working. Let's run our tests. Oh, hold on a minute. Spinal case, this is spinal tap should return the string this dash is dash spinal dot tap. I have never seen this film. I'm sorry to say. I need to watch it. I've heard a lot about it. So the first thing we want to do is, so let's actually first check that we've got this camel case going on. And we can check camel case by checking that there is a lowercase letter followed by an uppercase letter. So string dot replace. Now we'll do some regex. Every time that there is a lowercase letter, we're going to group that. Yeah, let's group it. Followed by uppercase letter. Globally, we'll replace that with the first group, which is $1 space, space $2. Let's try that with this. So this is cool. We've replaced every lowercase letter followed by an uppercase letter with the first the group up to the lowercase letter, followed by a space, followed by an uppercase letter. So now, and we can, let's console log that real quick. Let me just delete all of this. Boop. So check it out. This is spinal tap has now been replaced with there. So that's pretty cool. Now we've got our spaces back. We're turning it into lowercase like before. Nice. We're splitting it by spaces, and then we are joining them by dashes. So that's cool. Run our test again. Oh. Here's another one. Underscores. We've got underscores as well. No worries. We can do another replace. Let's replace all underscores with, oh, sorry, I should be using regexes. Underscores globally with a space. I feel like I'm cheating. Where is my thank you? So let's see what happened. I replace every underscore with a space. First, I do the separation of lowercase and uppercase. Then I replace all of the underscores with spaces. Then I turn it into lowercase. Then I split it along spaces. And then I join them with dashes. Run our tests. We did it! Pat, pat. I gotta recommend. Whoa, Carlos. That's a big chunky regex. Let's see what we got here. It's pretty cool, actually. So you're splitting it along the fact that there might be. Okay. Hold up. Let me delete my code, and we'll do yours. Return string dot split long. Look ahead. Yeah, no, this is good. Sorry, I didn't mean to say that it was bad. It was more like this is really good. So we're doing a look ahead for uppercase letters. Then we're doing or underscore or dash or space. Join with dashes. Oh, did I forget a two lowercase? I did. Two lowercase. That works too. I like this. I didn't know that you could do split with a regex. That's pretty cool. Nice. This is pretty cool. Nice one. Carlos speaks in regex. Love it. Nice one. All right, let's move on to the next one. We got one more minute. I'll do one more. And I realize I've done very little, but as you can see, we're not learning anything new per se. We're just doing some, thinking algorithmically. All right. We're doing Pig Latin. Pig Latin is a way of altering English words. The rules are as follows. If a word begins with a consonant, take the first consonant or consonant cluster. That looks important. Move it to the end of the word and add a to it. A. Excuse me. If a word begins with a vowel, just add way at the end. Okay. Translate the provided string to Pig Latin. Input strings are guaranteed to be English words in all lowercase. All right, I'm going to split this up into two cases. I like this. Big, like divide and conquer, right, folks? So we got this one here and this one here. Let's start with the vowel one. If the word begins with a vowel, just add way at the end. I think that's pretty doable. If the word is a vowel, return word, not word string, with way at the end. Else, move first or cluster of consonants to the end, add return string with a at the end. Okay. We'll give this a try. Let's start with this one because this one sounds a little bit easier for me. If. How do we check if it starts with a vowel? We'll need a regex. So if we want it to start, we need the caret. EIOU. So If this regex matches, meaning the first character is one of these, dot test string. That wrong. Return string with way at the end. Doable. Return str plus way. Let's give it a try. Algorithm should return the string algorithm way. Okay. I need to console log it, don't I? Algorithm way. Algorithm way. Algorithm way. Algorithm way. Algorithm way. What about with a D? Nah, nothing. Algorithm. Okay, cool. So we got that first part working. Now we need an else. Now things get a little bit more complicated. To grab all of the consonants and take them out. Okay. First, we need to match those consonants. Const first consonants. X. So that regex will be at the start. Now I could put all of the consonants or just match all of the ones that are not, whoopsie, not A, E, I, O, or U. Let me just make this a little bit wider. So this will match all of the consonants at the beginning. Yeah. A, E, I, or U. Cool. Now let's match that. So what's it? String dot. Let's console log that first. Console log string dot match first consonants regex. See what that gives us. Oh wait, I need a. Let me put one here. California. Oh, Michael says you need a plus. Yes, of course I need a plus. Let's do let's try that with Crow. Yeah, see, Crow should match CR. Thank you, Michael. There we go. Now we're matching all of the consonants at the beginning. Good. So if that gives us 0, then we've got our CR. Fantastic. So now that we've got those consonants, we then need to const new string equals. Now we need to slice. String dot slice everything starting at the length of the match. Const consonants equals slice consonants dot length. Console log new string. There it is. Oh, fabulous. So we've sliced out all of the ones that come after the consonants. And that takes care of this. With consonants and A at the end. We want to return new string plus consonants plus A. Oh, cray! Does that work? Let's find out. Let's run our tests. Phew, all right. Pat. I never really got Pig Latin, but if that's how it was, so how would Ramon work? Come on, Ray. All right. If you say so, Pig Latin. So what would this be? Amon way. Weird. I like it. Okay, cool. We are done. So let's go back to this. So we didn't get very far, and that's okay, because all of these are meant to be practice, and in my opinion, not required for what we're going to be doing tomorrow, which is our final lesson together, live, which is the cash register. So homework will be, and I'm going to put this in order. First, I'd recommend taking a look at the cash register project and just thinking about a solution, maybe coming up with one, bring it tomorrow. Tomorrow, what we're going to do is we're going to get together and I'm going to implement the cash register according to my thinking process. And just like we've done today, I'll take suggestions from you and we'll try and improve it, explore other avenues and that sort of thing. After you do that, then I would recommend doing the rest of these. These are great practice for thinking algorithmically. And as you can see, it takes a little bit longer. So again, homework first. Cash register, take a look at it. Come over tomorrow. Don't worry if you don't get anywhere. Just have a look at it and start thinking about it. The purpose of tomorrow is to explore how we can do it. And then do the rest of algorithm scripting. So with all that said, shall we do some Q&A? Any questions so far? Oh, yeah, let's start with Alistair's general wondering. I wonder if JavaScript has some kind of spaceship operator for general comparison. And I have no idea how to look that up. JavaScript spaceship operator. Ah, look at that. Okay, somebody else has wondered. Are you all familiar with Stack Overflow? It's a great place for folks to be able to ask and answer questions. And actually a really good way to level up your understanding of JavaScript or other programming concepts is to come in and if you know the answer, try and offer that. So let's see. Is there a similar operator in JavaScript? Let's take a look. As far as I know, there is no such operator in JavaScript, but you can use the math sign function. Oh, as mentioned in the comments, math.sign is not currently supported by all browsers. Check for compatibility. Is that MDN? All right. Just gonna have a quick sip of water. Okay. So we can use math sign to check the whether it's positive or negative. But I want to take a look at this. Where is it not support? Okay, it seems to be supported on all modern browsers, but might be not supported in older browsers. So in short, there is no spaceship itself. Triple M's asking, can we please go through the homework on currying and partial application? Absolutely. Let's have a look. Where is that? I'm in the wrong place, aren't I? Where is that? Where is that? Use. Wait. Currying and partial. I'm sorry, Triple M. Where is it? I can't seem to find it. Mix in, override, inherit. Oh, I'm looking at object-oriented programming. Oh my goodness, it must be Tuesday. Sorry. I was using Control F, but I was looking in the wrong place. Introduction to currying and partial application. So the arity of a function is the number of arguments it requires. Currying a function means to convert it a function of n arity into n functions of arity 1. In other words, it restructures a function so that it takes one argument, then returns another function that takes the next argument, and so on. Here's an example. Uncurried x and y, returns x plus y. This one is curried, is a function that takes x, that returns a function y that takes up an argument y that returns x plus y. So we can curry this. What? X plus y curried. Well, I would say let's play around with this. So we got our curried function. Let's console log curried x. Curried 1. That returns a function, which makes sense. In line 2, this returns a function that takes one argument. So you could think of it as const result function equals curried 1, for example. Yeah. This is a function. And this function takes one argument, y. Let's put in 2. This will print out 3 because this function here will return, the argument plus 1. This function will always return 1 plus the argument you put in. Let's take a quick sip. It's a little weird, but I hope that makes sense. Let's take a look at this other way of defining it, because this just looks very interesting. And that's just because it's just a bunch of nested arrow functions. And again, it helps to break these down. This is a function. So curried is a function that takes one argument x, and it returns this function that takes an argument y. So this is equivalent to this way of writing it here. And because, let's try that out. Because curried 1 returns a function, if we just call that return value, that's why it kind of looks like we're calling two functions next to each other. And that's because we're calling this function, which returns a function. So we're calling that return function. What if this has several? And you know what? I agree with Carlos. The arrow function is not more readable. I actually do agree. We can nest this too, by the way. This can go many times deep. Let's say we wanted to have one that goes 3 levels down. So curried 1 gives us a function. Curried 2 levels down gives us this function. So sorry. Let me start over. Curried is a function. If we call curried with an argument, that returns a function that takes an argument. If we call that sublevel function, that returns a function. And if we recall that third function, then it'll return 1 plus 2 plus 3, which gives us 6. This is useful in your program if you can't apply all arguments to a function at one time. You can save each function call into a variable, which will hold the return function. We saw that. The function reference that takes the next argument when it's available. Here's an example. Here's an example using the curried function in the example above. Oh yeah, see, that's what we did. Func for y, console log func for y2 gives us 3. Similarly, partial application can be described as applying a few arguments to a function at a time and returning another function that is applied to more arguments. Here's an example. Oh my goodness. Let's try it. So here's our impartial function. X takes 3 arguments, x, y, and z. and it returns x plus y plus z. And what we're doing here, partial function, is we're binding this to 1 and 2. Let's console log fn. That is a bound impartial. This is a function that's waiting for us to bind it to the value that we can call later. That's 13. All right, let's reset our code. I like this. Zenzer puts it much better. The last function will search for arguments. Thank you. So fill the body of the add function so it uses currying to add parameters x, y, and z. And we already did that. First, let's console log this. So first we return a function that takes y, which returns a function that takes z, and then we return x plus y plus z. Should give us 60. Shall we try this with arrow functions? X plus y plus z. It really does not look as nice. But yeah, we're returning a function inside a function. And that totally works too. Hope that helps. Any other questions? Oh, how would you solve the use higher order functions exercise in functional programming? Let's see let's see what the exercise is, and then we'll see how I would. Use higher order functions, map, filter, or reduce to solve a complex problem. Okay? So now that I've worked through a few challenges, you now get to apply them to solve a more complex problem. Complete the code for the square list function, which takes an array. Okay? Using any combination of map, filter, and reduce. The function should return a new array containing the squares of only the positive integers. Decimal numbers are not integers. Okay. An example of an array of real numbers is your function should not use any for or while loops or the for each function. Here's what we'll do. Filter out negative numbers. Filter out decimal numbers. Map squares of meaning. Filter out the negative numbers, filter out the decimal numbers, map out the squares. That sounds doable. The question is, how do I check if a number is decimal? I'm going to DuckDuckGo that. JavaScript number is decimal. Oh. What's the cleanest, most effective way to validate decimal numbers in JavaScript? Had to implement is numeric. Oh, y'all. Okay. I see. I should have looked at the chat. What am I doing looking things up? Let's see. We can use number is integer. Cool. Num divided by parse integer num. That's cool. Yeah, dividing it by 1 is equals to 0. These are all great. I kind of like number is integer. We can try all of them. All right. So let's first filter out the negative numbers. R.filter num is bigger than 0. Bigger than or equals to 0. That leaves us with, and we can use the console log to already be checking squared integers. -3 is gone. 4.8 remains, 5 remains, 3 remains. So far, so good. Let's chain another filter. Number dot is integer num. That leaves us with 5 and 3. I want to try the other ones. Num percent parse int equals to 0. That works. And we'll try Sandra's. 1, 0. These are all great. I might just leave this one. It's kind of short and elegant. Awesome. So we filtered out negative numbers. We filtered out decimal numbers. Now we need to map the squares. Num times num. Yay, there we go. Num times num. Or I think there's also mathpal. Num 2. Yep, both of these work. Run our tests. Hey, nice. That's a teamwork, Pat. I saw a question from Sandra as well that I wanted to address. Now that we did, well, we haven't finished it yet. The intro to coding in JavaScript, but I missed the application for web development. DOM, how to use JavaScript, what to use it. What's the best way to move on from here? And I do want to point to Carlos's suggestion. You've got the DOM tutorial in FreeCodeCamp and in their YouTube channel, which is fantastic. Just a word of caution, if I may. You've got the front-end development library certification. You've also got the back-end development and API certification. Both of these, I think, will be good. Like, these are meant to be done these are suggestedly done in order, but you can try out the back-end one if that interests you. About front-end, you will learn Bootstrap, you will learn jQuery, Sass, React, Redux, and the projects themselves. Couple things. I think the Bootstrap, let me just double check this. Where is Bootstrap? Sorry, bear with me, folks. Hold up. Where is Bootstrap? FreeCodeCamp curriculum. I believe, I could be wrong, but I remember seeing that the Bootstrap version, which is a front-end framework for design responsive web pages and applications, it might be a little bit out of date, this version. jQuery is not as widely used anymore. So you can, my point is, you can totally, I think the React uses classes instead of hooks. So this is totally usable, but it is a little bit out of date. That's not a bad thing. The other stuff, super timeless. But maybe check out their YouTube channel. I haven't looked into that yet. Null3 is saying, I'm doing the front end now. I'm getting troubles with React and Redux. I'm sorry to hear that. Carlos makes a good point. I think it's better to start building your own projects with HTML, JavaScript, and CSS first. I don't think that studying Bootstrap or jQuery not worthy. I mean, listen, there's a bunch of websites. There's a bunch of websites out there that will use Bootstrap or jQuery, but I agree with Jeremy. You don't have to do it. It's a bit legacy. The legacy responsive web design. Yeah. There's a new one that's really good. And in fact, my friend Jess, who, by the way, is a much better teacher than I am, and very kind as well, is doing a bootcamp on that, which I highly recommend. It's on classcentral.com. Yeah. Brett has a question. Oh, wait, null. Or num is bigger than 0 is the same here. Yeah, unless we want to count 0 as positive. That's why I was like, num is bigger than or equals to 0. So I don't think either is wrong, and I don't think they were going to give us any zeros, but still worth considering. If you want HTML, CSS, and JavaScript, there are cool projects in the YouTube FreeCodeCamp. Don't take my word for it. Absolutely. Thank you very much. Okay, Brett's got a question. Return sorted array exercise. How does using concat prevent mutation of the global array and without returning a new array? Let's give it a try. Brett Cabot is asking about return sorted array. And that would be in under functional programming. Yeah. Return sorted. Oh no, I can't find it. Did I forget to expand it again? I forgot to expand it, didn't I? No, I didn't. Return sorted array. Sorted. Return a sorted array. My bad, my bad. Without changing the original array. Let's give it a try. A side effect of the sort method is that it changes the order of the elements in the original array. In other words, it mutates the array in place. One way to avoid this is to first concatenate an empty array to the one being sorted. Remember that slice and concat return a new array, and then run the sort method. Use the sort method in the non-mutating sort function to sort the elements in the array in ascending order. The function should return a new array and not mutate the global array variable. Okay, so one way to avoid this is to first concatenate. So we want to return sorted, right? So we can take an look at Null giving me the answer here. Concat r sort num1 num1 num2 num1 minus num. What happened? This got sorted. Console log global array. And this remains unsorted. If we don't do that, let's see what happens. Then the original array gets sorted. It gets mutated. By leveraging concat, which is essentially giving us a new array, we're making a copy of it. Making a copy, you say? Could we use the spread operator? Yes, we can, because we're making a copy of the array. Another way to do that is with slice. Good old slice. Same thing. Make us a copy of the array. So we are mutating this copy of the array. I think that's your question, right? How does using prevent mutation of the global array without returning a new array? So using empty array concat r, we're making a new array. It's not the same one. Because concat, as we said, remember that slice and concat return a new array. That's it. All right. We'll take one more question from Jeremy, and then I'll let you all go about your day. Will there be a bootcamp for quality assurance? I've completed the other pass and need to work on QA. Now, I assume you're referring to this here in FreeCodeCamp. In all honesty, Jeremy, this is the first time that it's come up. No promises made, but we can look into this for a future bootcamp. Watch this space. All right. I think that's everything for today. Let me go back and look at homework once more. So tomorrow we'll be doing the cash register. Oh my goodness, how is it already the last one tomorrow? It feels like these weeks flew by. So tomorrow we'll be doing the cash register project. After that, we will have completed the bootcamp and be able to get our free certification from FreeCodeCamp. Now, so what I recommend for tomorrow is to have a look at the exercise. Just give it a read, start thinking about how you might solve it, and then tomorrow I'll come and show you my solution. And then we can talk about how to improve it. When you have, after that, if you have the time, if you have the energy, remember rest is very important for this as well. Then you can do the rest of the intermediate algorithm scripting section. What I want to say is thank you all for sticking around this far. This has been magnificent to be able to do. It's incredible that tomorrow is the last day. I want to say also, remember, if you get stuck on anything, you've got the forums, you've got each other, you've got the Discord. Go to group.classcentral.com. And if you're stuck on anything, just drop a question in there. If you're looking at questions and you think you might know the answer, give it a try. Putting thoughts to words is really, really good way to learn. All right. I will say thank you all for joining today. I wish you all just the most wonderful rest of your day. And take it easy, folks. See you all at the next one. Bye.